Broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everybody. Welcome to today's webinar called Structural Design Made Easy. So thank you for joining me today. And I'll be showing you just how design is made easy. So a little bit about myself. So my name is Gtcx, and I am one of the application engineers here at Gtcx, and I'm responsible for providing you guys with the latest webinars, demonstration, and I also provide technical support and training for some of our products. So prior to joining Gtcx, I worked as a structural engineer for a number of years, and my experience varies across a number of sectors, some of them, to name a few, retail, residential, and commercial. And I have designed structures in my time to steel, concrete, timber, and in masonry as well. So you have a copy of this handout which has been uploaded to this webinar session, and within that there are some interactive links where you can reach me by email address, so it's jamil.dida@com, and you can also connect with me on LinkedIn. Feel free to reach out there, and those direct links within the handout. As always, we always get asked the question whether these webinars are recorded. So the answer is yes, the webinars are all recorded. And once they're recorded, we upload them to our Gtcx Content Center. Gtcx Content Center is where you find a variety of materials in there. So that can be anything from tips and tricks to industry workflows. And some of our experts from the AEC, MFG, and structures industry also look to share the best practices as well with you. So all of that's available on the Content Center. So allow up to 10 working days or 2 weeks for this webinar to be uploaded to the Content Center. So an overview of what we will be covering today. So let's take a look at what we'll be looking at today. So to start with, looking at the all-important BIM as structural engineers. A lot of the time we tend to start with a conceptual model either from the architect or the initial designer who models the structure. And I will start with a model in Revit, and I would look to then export that to our structural design and analysis tool, where we'll be able to apply 3D climatic loads, generate loads on the structure. And then we will be able to get some FEM results. So obviously we want to be able to look at forces on the structure, displacement, and also along with that some steel and concrete design results. Also, we've got planned is taking a look at the report generation, so the output of reports of all that design. And finally, we'll look at the design modules. So one of which is a steel module where we design steel connections. And finally, the concrete design module. Oh yes, so please stay tuned for the following. So I hope you guys enjoy today's session. If you have any questions as I'm going along, feel free to pop them in the chat window or the question. I will try to pick these up at the end of the session. So there is an opportunity to hold a Q&A session at the end where I'll pick up your questions and those. So it's time now to get started. Let's get. So if we start off with the workflow, starting with the model in Revit. Here I have a basic portal structure in Revit on the screen, and it consists of, you can see, steel columns, purlins, bracing as well. So at the moment, this really is a conceptual model. We need to be able to take it to the next level to perform the structural design. So how do we go from Revit then to structural analysis and design? So that is the next thing. And that is a very smooth and easy process. So that, leaving you guys to focus on the more important areas, such as analyzing the results and designing the structure itself. So I'm going to make a few changes to the structure. The bracing at the back, I'll add a purlin over the center here. As you can see, currently the ridge doesn't have a purlin there. And I'll also add some bracing in the last bay. So if I take a look at the tools that we have available here, with the Power Pack, we have a variety of tools, one of which is the structural analytical tools. Now, with a model such as this, sometimes actually it can be, we've all been there, seen it, we have inconsistencies with the model sometimes where some of the nodes don't quite intersect, we don't know where the common nodes are, some elements are offset. Okay, so in those instances, you need to model up to scratch to make sure it's actually structurally acceptable. So with the Power Pack in Revit, detect those errors and use the following tools. So you can see here, we can use, we can reset the analytical model, we can trim or extend, and also stretch to any nodes. So it's very important. And here comes the exciting bit. Oh yes. So with the Bim Connect tool that we have here, you're able to export models to and from Revit and Advanced Design. You can import models as well, and you can see models. So the important thing here, you'll notice, I'm actually only working with one model here. So that's the model that we're seeing on screen in Revit. So I'm going to be using this model, one model, all the way through, rather than having two separate models, a structural model and an analytical model in Revit. We've just got the one model here. So it's no matter where we start, whether that's a structural model in the structural analysis software, such as Advanced Design, whether that's a analytical model in Revit or a conceptual model, you can still get to where you need to be. Streamlined and efficient workflow that we launch this automatically. So we can either export the model, we can launch it automatically with Advanced. So you can speed that process up even by automatically opening it with Advanced. So here I've chosen to automatically open. Add to the mix where you can also generate a report, which will give you a detail, give you some detail of which elements have been exported to Advanced Design. And you'll notice later when I make some changes. So I'm going to take this model into Advanced Design, and I'll be making some changes to the geometry. I'll remove some elements, add some additional elements, and change some existing. Then I'll look to synchronize this back with Revit, synchronize in Revit all the changes, and you'll see just how easy it is to bring those changes back. So here we can see on screen is our model for Revit. Okay, so the geometry has come through there. Okay, so as I explained, I'll just look to add a central ridge beam over here with the apex. I'll just copy this across. It's very easy to model in Advanced Design. A lot of the common commands are familiar and akin to AutoCAD. If you look here on my screen, you have a ribbon at the top, very similar to AutoCAD. We also have at the bottom where you can use a series of shortcuts for modeling as well. So the point here is that you don't actually have any nodes to deal with in the modeling phase. So your life is made easy in that you won't get any nodes which you have to deal with in the modeling. So it's just geometry. So I'll just copy this bracing here to the end base. You can see just how quickly I've done that. And I'll just remove this at the back so that we have a couple of changes to this model. Next up, I will look to change some of the column sizes as well. Again, in Advanced Design, it's simple to manage your model. You can easily find the sections in your model. You can use the subsystems to create folders. We have a variety of tools to filter elements and locate them easier. So it's easier for you to manage this model. So I'll just increase the size of these to a 254 by 254 by 73. So I've gone from an initial 203 by 203 by 2 UC, then up to 244 UC section. I could have used my favorite section, 346 UC, but in this instance, I don't think I would have quite done the job. Otherwise, I would love to use that section. We all have favorite section sizes. As a structural engineer, I'm actually interested in knowing what is your favorite section size. So if you could please put in the chat box, it would be interesting to know what sort of section sizes are people's favorite. People have different preferences, so it's just interesting to know. Feel free to pop that in the box. Okay, so now then, we also have a check control command in Advanced Design as well. So earlier we saw this tool in Revit, which shows you where you can detect errors and correct them. The same here, again, we can use in Advanced Design. So if there are, again, any elements which are not quite intersecting, or you have any elements which are not in plane, you can very easily run this command. The following tools to correct errors. So they are very much similar commands that we have there. So this saves, takes out the manual task and having to sometimes spot the difference or manually make changes to the model and send it back again. We have these commands, series of commands that we can use to correct those errors. Okay, now it's time to send this back to Revit. So I'm going to export a Gtcx file. So the Gtcx file is the common file which Advanced Design and Revit use. So this is a common file used between Advance Design and Revit to with each other. So I've created a Gtcx file. It's exported supports, results. I don't think as of yet, and it's written GTC file. Okay, so let's head over now to Revit and see what that looks like. Okay, so back here in Revit now, as you can see, we're expecting that the purlin over the center here at the ridge. And we're also looking at removing the bracing at the back. And if you remember, I added some bracing to the front bay. Now I'm just going to very easily synchronize here. So in this case, I don't actually have to import the model. It's simply a case of synchronizing those. And when I synchronize these changes, I have the option to actually narrow this down in terms of, as you can see in the legend, new, modified, or any deleted object. Okay, so you can see all of that on there as well. Okay, so I'll just load these into the project, so the changes that we've made. Okay, so you can see it's loaded now. So from the legend, you can see here that 10 of the objects that was primarily the and the purlin we added at the center. Got many more objects here. I think that's maybe down to not mapping correctly. I might have skipped the mapping stage when I originally imported into Advance Design. Deleted. We've deleted the bracing at the back. Remember. Okay. You can very easily narrow it down. I don't have to synchronize everything in one go here. Oh no. So I can very easily break this down into 3 simple steps, which I'm going to do here in terms of firstly synchronizing, for example, one of these either new, modified, or deleted. And I can also see what has changed as well in the details. So changed attributes. If you have a look at the change attributes, the type, look at new, you can have a look at this. So if I expand on this, okay, so now if we look at this, the host, which that value is null because we have the purlin of the for the GTC file value in Advanced. It's showing a section size there. So section size, the new section we've got there. It's not only the section sizes, it picks up material, centricity, really almost changes to the geometry, any releases. It will pick up those changes, and you can synchronize all of these changes one by one. For example, add a steel beam where you've changed the material, you've changed the eccentricity, you've changed the releases on there as well. You can, for example, choose to just update or, just one of the changes. So it's down. You get full control of what it looks like. So I'm just going to keep your eye on the model at the bottom there, and you will see new items magically appear. So keep an eye on that. The beauty also is at each stage of synchronizing, you can save track of any changes that you've made. The number of elements or exactly what has changed in between. So now if we take a look at the model, it's saying 0 items, and now we don't have any more new items. Simply because we can see on screen now, it's applied the changes for the purlins there and the bracing at the front. So very easy there. You can see just with I've managed to update this model instantly. Okay, next up then. So there's the bracing. Right, so we'll look at the deleted elements. So that's the bracing at the back there. It's deleted. So I can choose to keep the changes. I'll apply the changes. No to the report for now. If you keep your eye on the bracing here, this is the bracing of the structure. Okay, there we go. There's the bracing. Deleted is now showing 0 objects. So modified is what we've got left with the columns. If I then choose to enter modified, so we can narrow this down to beams and columns, so I'll select columns here. Let's just double check so we can see there the difference. It's going from a 203 UC to a 254 UC. Time to accept our changes. Okay, so this part of the process really, it should not be time consuming. As you can see here, it's very easy process to switch between Revit and Advanced Design. Whether if I was making changes in Revit to carry through to Advanced Design, this process is very much the same synchronization window, the same tools on both sides. So now columns have been updated as well. So if I select one of these columns, there we go, a 254 UC section. So I'm happy with that. Right, so if you go back over to Advanced Design, then it also exports the levels here. I forgot to mention at the beginning. If you have any levels to Advanced Design as well. Okay, so I'll just quickly show you here. There's the levels. Although for this type of structure, the levels don't quite apply. There's not many levels here. So now let's look at applying some loads onto this structure. So let's add some loads. So we have a variety of loads we can add. We'll add some dead loads, live loads. We can also add in seismic temperature loads as well. You can see really quite advanced the engine here. I'll add in a dead live snow and wind. We've introduced a series of on selection commands here where you can very simply create loads on selection, load areas. I'm just going to enclose this structure with a series of load areas, load panels, which are going to transfer our loading onto the elements. And I'll just do the front. See load areas on section. You can see just how quick that was. Very simple. I'll just do the same at the back here. A lot of these commands are on selection, so applying your loads. Instead of having to, for example, if you're creating an area load, rather than clicking on each extremity or each corner, you can simply select your element choose loads on selection. Please, let's add another one here, and we'll just copy that over to that. There we go. Yeah. Okay, so we can close in load areas, and we're ready now to apply our loads. Copy that one. Okay, so if we take a look at the wind load, for example, the wind loads it's a very powerful 3D climatic load generator for wind loads, snow loads. From the wind load settings, as you can see here, climatic generator, whereby you simply choose the location of the structure, so approximate location, or wind speed reading. So if we take a look here, if I click on this, we go into the interactive map, and we can choose the location from here, approximate location. So I'll just choose somewhere which is a bit further up north, so we can see speed at 22 changed to 31. So that's changed the speed, and it will automatically calculate your dynamic effects as well. So no need to spend large amounts of time calculating. So we can rely on the automatic generator to create those wind loads in a matter of seconds. As you can see here we have our wind loads. There we go. We have all of our pressures here. You can also modify them individually if you wanted. So if I now also do the same for automatic generation, closely, you'll also see accumulation, the snow load accumulation in the corner, where we have difference in the height of the roofs. Okay, so we've got that difference in heights, and also calculates the accumulated snow load as a result. So the snow load there. Okay, so what I've got the exact same model here. Just to speed things up a bit, I've added all the loads and supports to this model, exactly the same as well. So now I can take a look at some FEM results. So with the FEM results, might create a new analysis here. FEM analysis, if you look here, you can also choose to automatically update your reports, making it easy for you here. If you make any changes to the structure, with that option ticked, you can automatically update the report to suit any changes in the model. You compile and generate that report. We'll also run a steel design on this. So let's just let the engine calculate that, and then take a look at some of the forces and FEM results on this. So we haven't gone on in the analysis. Okay, that's fine. Mesh, you can see 6 seconds just to mesh that, and you can see what it's doing exactly at each step. You can see step by step what it's doing. That's launching to the steel design. So now you can see now we obviously have a series of nodes which we don't have any of that modeling phase. We'll get a result at each of those nodes. In this particular model for the bracing, you'll notice the bracing hasn't got any, so there's no meshing for the bracing, simply because I've set the settings for the bracing to be tension compression only. so they will not attract any load on them. Specific compression only, in case you're wondering what's going on. So here we have our FEM results and steel design results. Okay, I'll just turn the nodes off here. Just switch to a 3D view. We outline the sections. It's a bit better. Over then to the results. This is the important parts to see how it's behaving. So under the dead load, with self weight, we're looking at the dead load deflection of 50 millimeters. And I gave the views as well. So this is one of those customer-driven enhancements. With Advanced Design, we have one major release a year, followed by a series of updates throughout the year. A lot of these updates often include custom enhancements, and this is one of those custom enhancements we're looking at here, is to be dynamic views. Now, these dynamic views, here, you can save your results, so we can save the view there for the reports. We can use them externally for, in emails. You can save all of those views. Save you time having to flick and go through all of the buttons to choose your results. You can instantly access them. So I've saved a few results here. So, okay, if I look at now the steel design results, so let's take a look at steel deflection. Okay, we have 79% as the maximum, probably the purlins, I'm guessing. Okay, so 79%, there we are. Yeah, so that's within the purlins. And I can also save that view. Maximum deflection then as a denominator at the ADM 719. What else do we have on offer on here? Strength. So strength, the work ratio. So we have a series of work ratios. As you can see, it's broken down. You can have bending and axial force, bending, shear, maximum work ratio. So this is a prime example of it can be simpler to be at the same time as complex as you want it. To make things easy, choose the maximum work ratio. Okay, so we're looking at so much here, 52% perhaps. So while I'm on the topic of work ratios here, we're looking at 50%. One thing to do again to make it even easier, optimization, is we can set limits to optimization. By that you can, for example, set the limits to stop at, say, 8%. I know when I was designing structures, I used to try and aim 80 to 85% for the initial design. So that leaves you, a bit of bunch changes to the structure. 80-85% just a good starting point. So you can set you up to maximum, we'll say 85%. If then the elements are working harder than that, it will automatically suggest alternative size. So you you can accept changes to the structure for the optimization, which I'll show you in a second. Okay, so we have now a series of results. If we look at the bottom left, we have all of our views that we looked at for the results saved here: displacements, forces, stresses, deflection, strength. So what we're looking at is, at the moment, this view is of the work ratio. I can simply switch between results, placements. I can instantly see the results there, along with an animation. That's very handy. The animation is a very nice tool, just to simply have a look at structure is behaving globally. Okay. Forces. So there's our view for the forces. And I can also put values on diagrams here. To make it even easier, I can just show on the diagrams if I wanted. So there's our forces view there. Okay, with the slider scales the text. Over then to the stresses, you can see just how easy it is now for me to toggle between. Instead of having to choose my type of result, the force on there, the combination, just once. Okay, so no need to reinvent that wheel. Set your results once, save those views, and take advantage of that by just simply switching between those within, click or two. Okay, so there's our views here. We can also use these views in reports as well, which I'll show you a bit later on. Now, take a look at where these numbers come from. So what we're seeing here for this type of result, so we're back to the work ratio again. So I want to know where that 52% is coming from. So it's interesting for me to know. If I open the shape sheets here, okay, very easy. Here we can see that 54% reflection here is coming from, there's the reference to the mesh and the unfavorable case. So case number 233, that is resulting in worst case deflection. So it will always show you worst case deflection, which case is resulting in that, which mesh, which node is where it's highest. That's the difference. If we now head over to the cost strength, the strength checks, here we can see class 3. Okay, checks here, tension, compression, shear, biaxial bending, all with reference to the Eurocode. So you can see, for example, 6.2.5. Very easy for you then to refer to that clause, and then if you need to make any changes to that calculation, any calcs, you can introduce that as well. So here, what we're looking at is the worst case check here is bending about y, 52%, due to case number 187. Another important one to look at here. We also have verification to clause 6. Code. That's 60% and 30% there we're looking at. And it's got the calculations there. Now, over to the optimization. Again, this is very, very fun and easy at the same time. So I personally have great fun with optimization. I set my limit and then I optimize the structure based on that. So if we optimize the structure here, you can see some of them are way overworked. So it's probably something I need to revisit in the model, perhaps check the loading in that area, check the elements if they're modeled correctly, perhaps the meshing. Okay. So we can see that right where that's coming from is stability 6.61 and 6.62 at the bottom. So it's highlighted there, so you can very easily see, your eye is drawn instantly to where that that worst case result is. Okay, so 16.2 value there is very, very high. That's what's causing that. Okay, we have a couple of other ones. If you had a look there, so the percentage I set on here was 70%, I think. So anything over 70 is then highlighted in red, saying I need to optimize it. So I can simply optimize by clicking on the accepted solutions individually, one by one, as you saw there, like that, or I can manually choose the section size. Now, you get to choose the optimization. So in the properties earlier, I actually set the optimization to by weight, which means it will optimize, it will choose the lightest alternative, which will work then. Alternatively, I can choose a section size manually as well. We can do it manually. You can choose the solutions one by one, which is what you saw just now. To make it even easier, why not just accept all of them if you want? So if we're happy with most of the changes there, you can click on accept all, and it will accept all of the solutions. So you've got all the lightest or possible alternatives which work there. You simply accept the changes and then run the calculation again. Okay. One other thing is that you can also run a chained optimization. You can set a number of iterations where it will keep optimizing the structure until you've got that optimum structure there. So now we've gone from the BIM workflow, so we've gone from Revit or / modeling to applying our loads and then being able to look at our FEM results and some of the steel design results that we just saw now. But it's also important to get this information on some paper. So the output is just as important. Knowing where the numbers come from, what we're getting from our design, it's very important to get those reports out. Again, this should be an easy task to generate the reports, as you just see now. So I'm going to simply generate a report here. This is one I've got from before. Previously, I'll just delete the contents there. And then I'll just quickly show you, run you through this. So just slow this process down a little bit so you can see just how flexible this tool is. So I'm creating my own chapters here. So the report, again, there's a certain element of tailoring to this. You can tailor the report so that it caters for your needs. It can be as concise as you want, or as informative as you want. You can have all the types of results in there if you want, or just select a few results. So from here you can see with my result tables, I can very easily narrow this report down so that I don't have reams and reams of paper with unnecessary combinations and loads. I can simply choose my load case and just the members I'm interested in. You can see here, I'll choose a column and the dead load case for the displacements. And here we have our views, post-processing. So we have access to our views here, which we saved with the results. As I mentioned earlier, if you make any changes to the structure, to make it even easier, it will automatically update this report, and it will automatically update those views for you. So you're just doing this initial legwork once initially, and then you're set to go. Okay, so the next one up is forces. We'll just add some results for the forces there. So what you're seeing here is a report generator. We have some preset reports, if you like. So you can print off bills of quantities, load distributions, load combinations. You have those preset sort of templates. You can also save your own templates. So what I'm creating here is I'm creating the contents for this report. I can save this report as a template, which is what you'll see in a second. And then if I work on a similar project, make things even easier. Oh yes, we love the word easy, don't we? Easy. So make it even easier. When we have another project, I can very simply load the template on there for the report and just click the generate button. Simple as that. So here I'm just trying to create several chapters here, just so we've got some different types of results in the report. Okay, so steel analysis, these are the type of results we have. Everything is presented in tables here. So line by line, you can see the type of results, so shape sheets. And in here, I'm just going to narrow this one down. So I don't want it to show the shape sheets for every single element there. We go by system and just choose from here, define specific selection. So choose columns there. And then we can add in our deflections as well, max work ratio with that, and then generate our report. So you can see again exactly what it's doing step by step. You kept in the know-how there. And one other thing which is very important related to reports is you get to choose the output. You can either output the report in a Word document, you can output it as a PDF, or even an Excel sheet if you want. You have all of those options there. This one will be in Word document. So if you have it as a Word document, you can very, very simply alter the report. You can introduce hand calcs into there, make any changes. So let's open this report now. So the thing about the report is once it's generated, it launches automatically. And you can also open the report directly from the document tab here. As you can see, everything's very nicely organized, so access to all of your views and also the reports there. It's created, you can see from there, one I created earlier was in an Excel file, so you can create them in Excel file. So I'll just open this one, the one created with Word, Microsoft Word. So this is the benefit of outputting with Microsoft Word, is that you can tailor the report as well. This particular one, I don't think I included a cover sheet, but you can also include cover sheets, set up a template which includes your company logo, your company address and details. You can set that up as a template to be used in the cover sheet. Okay, so it's very simple to apply that. So here are our views which we saved for the results. So I'm looking at forces there. Just quickly run through some of these. Quite a few forces that we have here. Now there we are. Our forces view that we saved. Steel design, then the next one. Max work ratio. Okay, so we have all our results there in the report. You can see the report, of course, can be even shorter than this. It can be even simpler if you wanted, or even more complex if you wanted that to be. So next thing is being able to design the steel connections. So we've got all of this in one place now. So you've gone from modeling to your loads to firm analysis, design, and then reports. It's also important to be able to design these connections as well. So again, we've got all this in one place. You can actually design the connections in Advanced Design as well. So you can either open that with the design modules or export it to the standalone module. So I'm just going to open it with the design module here, one of these connections. And then let's take a look at this. So it's just taking a while to load. Okay, there we are. So we have a couple of views here. 3D view of the connection with all our forces on there. You can see that it needs to be able to resist these forces, a moment of 123. You've got an actual load and a shear force there as well. Okay, so that's what we're designing this connection for. It should be nice and easy. Okay, there we go. So what you'll notice here, that is Advanced Design initially, to make things even easier, provides you a starting point for the connection. So it will model a plate with some bolts initially, which are relative to the depth and width of the elements to be connected, as you can see here. You then take it from there and you can modify that connection. So it's not so much having to model it from scratch. It's almost a template, which it automatically applies. You just take that to the next level. Okay, so we have a series of bolts here with that plated connection. Geometry. So here is where all the magic happens. Changing this connection. Members, these are carried through from the main model. stiffeners, it's added those plates. So it's suggested 20mm thickness here, but I can reduce and increase that if I wanted. So 20mm, if you keep your eye on this, on the drawing on the right hand side. So I put it up to 30. Interactive drawings which update with that. It's a bit of an overkill, but I'm just changing that there. At the moment, the plates are relative to the size of the elements we connected. You can override that by entering in an exact value as well. Again, very easy to do that. So 300 by 900, here's what we're looking at for this example. Over then to the bolts. With the bolts, I get to choose the diameter of bolts, the staid and the standard, and the grade. Getting a bit tongue twisted there. Okay, so position. So these are the bolt distances. Now, again, bolt positioning, it should be very easy, as it is here. You can model with a peace of mind knowing that the engine will actually check for you if you're to check to see that you're within the tolerances, so you're within the limits for the spacing, for the edge distances and interim spacings. If you're outside of those limits, minimum maximums, it will alert you and let you know. So there's no need to check any of that manually. Very simply enter your distances in there and away you go. So I've got a distance there of, you can see 100mm that we're looking at. Okay, so I can enter my own distances in there. Very simple. And the other ones vary, I think. So the other ones are varied, so I can change this if I wanted to reduce it, bring them a bit closer together. Going from 100 now to 80. Okay, so that looks a little bit better. Bolt column then. They vary at the moment. I can also change those if I wanted. Put them all of them at 200, for example. Okay, so this connection, I have made quite a few changes here. So this connection, I'm going to run through this quite quickly. This connection may obviously not pass the checks, but again, I'm just showing you how easy it is here to make these changes. Type of holes you can choose: round, countersunk, or slotted. If you've got any deflection heads, you put a slotted hole in there. You can also add a tolerance on top of those holes. So on top of that 2mm, you can add an additional tolerance on that. Design settings. Here are your design assumptions. You can override it, put your own safe factor in there, as we can see. I'm just going to leave that as it is. Of course, I could have simply hit the calculate button, as you'll see. Combinations then. So these are all the combinations and the loads definition which are carried through from the main model. So here we go. If we take a look at these, we have a shear there, a moment, and a maximum actual. So these again are the forces which it needs to resist. These are carried through automatically from our FEM analysis. Now, simply calculate. To make it even easier, we could have just opened, right-click, open the connection, and then simply press the calculate button to calculate the connection for us, just straight off the bat. Okay, so we're looking at here, I've made changes to this. The tension, okay, so tension's a bit too high for the bolts. You can see it's the top two bolts there. If we look at the bottom right, very easy to see which the bolts are failing. You'll highlight it in red. So it's the top two there. I can either go back and change the size of those bolts, perhaps maybe increase the bolts to get rid of that. But we have all the work ratios here, which are listed in order of priority, basically. So the highest work ratio to the lowest. So very easy presented here. You've got all your worst case combinations which contribute to it as well. We have those combinations. Combination 139 for that one. Errors and warnings. So here you can very easily see exactly what you need to correct. And so I've got the bolts are clashing with the web, I think. Probably need to revisit that. So bolt hole spacing needs to be revisited. Okay, so you can very easily see exactly what you need to change in there. And it will also tell you the load cases which are causing that as well. So if that load case is not critical, maybe you could go back into the loads and remove that load case from there altogether and run it again. More importantly now then, it's very important to be able to generate the reports and drawings from this. Yes, this is the icing on the cake here, guys, in being able to output the drawings, which can be used for fabrication purposes, actually. So here I'm just adjusting the scale of this connection. We see the elevation. There we go. Reposition that one. You can add in additional views and sections as well. I can restore the layout to default. If I want to take this a step further and detail this, build upon the detail and detail it even more, I can simply save this as a DWG, which will allow me to open it with an AutoCAD. And in there, I can very simply make changes to this drawing. Again, you got that option there to customize it. Drawing templates, you can add your own company template in there. In this location, you can add it in there, and so you can set it up with your default. So you can save this as a DWG to open in AutoCAD as well. Quickly save this. Okay, so that's the interactive drawings there. So then the report, just as important, we want to be able to get the report as well, the output of those results on paper. So from the reports settings, again, this is even easier. It's a simple tick box exercise. Tick what you need and untick what you don't want in the report. So there are several levels of report here, intermediate, simplified, and detailed. So I can very simply uncheck the information which I simply don't want to include in the report. So uncheck all of those. Okay, there we go. He's having a bit of a think at the moment. We can also preview the report as well. So at the bottom you see a preview report option, and below that you'll see an option. You can either export it as a PDF or a Word document. If you want to customize and take it even further, you can output this as a Word document if you want. In this case, I'll just preview the report. Yeah, okay, so we'll just take some of these off. So there's the different levels we're looking at. So from combinations, so you can avoid the combinations and have one just separately for combinations. Now let's preview the report. You can preview from there. You can output as a PDF or Word document that you can see. Okay, so this is the preview one. Okay. So, right, so now here's the report. We'll look at the report here, the report preview. So this connection, it tells what the maximum work ratio is up top. So there's 160%. If we scroll down through the report with all our information which we chose to include in this description, you can see all the references to the Eurocodes and the tables. We're looking at the holes distancing here. The maximum distance for the right holes have failed. If we look closely, it's very easy for an independent checker to follow this. You can, if you output this as a Word document, you can add of course, you can add your hand calculations against this as well. So we have all our calculations there. So as part of those, there's our report. So you can see just how that information is presented. Right, so there's the report. And now I'd like to switch over to a concrete model. So that's the end of the steel. So now if I take you on a quick detour through concrete, so this one will be a lot quicker. I'll just open a concrete model and take you through the design module for concrete members. So this is a multi-story concrete office building which I have here, consisting of beams, columns, slabs, and a shear core. Okay, so this model I've already analysed it, so I can simply open the model with analysis again. You can also, if you analysed it once, you can open it with the analysis. I'll just switch everything on for the structure and take a few to look at. Okay, for instance, that's the load. So if I pick this beam here and open this with the design modules, so the process up until this point is very much the same, whether it's steel, timber, or concrete. Where it mostly changes is at this point here with the design modules. The design of the material obviously going to be different because they're different materials. So here we're looking at a concrete beam. We are 3D views there. Got a section view as well. Over in the geometry, we can manipulate this beam. So almost now we've gone from a global design to a local design for just this one member on its own. So we're doing all of this in advanced design. Don't forget, we're still in advanced design here. We've singled this beam out where we can treat it as an individual beam and modify this. We can add holes in this for any surfaces, any openings, depressions as well. You can modify this beam to suit the situations that you have that you're designing for. Okay, we can add open links there as well. Quite a powerful tool, this, the design modules. So you're taking here, you get to take that to the next level. So the design to the next level here. All our concrete assumptions. We have creep, all the humidity there, ductility class, fire calculation. Okay, so our assumptions. We can change the grade from here as well. Ductility class A, probably go for, you can change it to B or C if you wanted. So this is your everything in one place here. So I can change the cover as well. So this is the stock list, the list of reinforcements. So if I can simply choose what I want to do with the calculations. So here we can see 50 mil bars are not really standard here, so we can untick those. So it won't suggest there's a solution. Now, reinforcement assumptions. So we get to choose what the assumptions are. Longitudinal bars for your transversal bars, your stirrups or your links. Automatic, we can choose, override that, put our own diameter in there for the links. Shape codes, we want stirrups or pins, multiple links, spacing, so at the bottom I can see well. So here we're looking at spacing. At the moment it's in packages, so different types of spacing. We can choose to have uniform spacing as well. Okay, so all of them at 200mm centers or 150mm, for example. Really down to you. You can choose your compensation method here. Okay, so those are set as transverse bars. We look at assembly bars, not much there. Anti-crack bars. So for any sections which are relatively deep, you're getting close to say 900-meter deep beams, you need to introduce anti-crack bars there. For this we can change the assumptions for that. If it's a deep beam, it will automatically suggest anti-crack bars for you. Splice bars. So you can see we're almost getting into detail in a sense. We're taking that design one step further. All within advanced design. We've got the anchorage, hook lengths there. Size mix, not so much of a big concern here, but maybe in other countries. Okay, so the bar constraints, special features we have as well. Really quite important. Okay, so you can very easily design your elements in Advanced Design, as you saw with steel, with the connections. You can do the same with concrete elements here, whether that's a beam, a slab, or a column, or shear walls. Okay, so the slab design is relatively new that we've introduced into this the latest version. So here are the internal efforts. You can add your own in there. So let's just simply calculate and see what it returns for reinforcement. You can simply, again, straight off the bat, press the calculate button, and it will automatically place the reinforcement in the element for you, which it thinks it's a good starting point what will work. So it's predominantly, we've got 4 bars on the top, so 4 H20s in the top, and then 2 layers of 10s at the bottoms. I probably could adjust that. So 3D view here, we can see all in detail just how it looks. There we go. If there's any clashes, very useful to be able to see that. We have a series of results at the top as well, which I'll show you in a sec. So that's what that looks like there. And then at the other end. So don't forget, we can also modify this reinforcement. You can take it even further, where we have a link with Revit as well. We can export the theoretical required reinforcement back into Revit, and in Revit, the detailer, the draftsman can modify the individual reinforcement. So there's 2 things I need to work on here: ductility class, and then generating new mark combination. So we've got longitudinal, so the main longitudinal bars up at the top are 100%. I probably would look to increase the number of those bars, perhaps add a second layer in. If we now look at the results, okay, so the type of results here, very easily presented. Bending, shear force. You can choose the envelope there. Choose the type of result you want to see on there. So graphical representation. Axial force, I've introduced that into the mix as well. So all results. In interactive ruler simply lets you click on any point on this diagram here, and it will give you the result at that point. Reinforcement then, so provided against required here that we're looking at, provided AS against required AS, or your main reinforcement, and also the transverse reinforcement. Okay, so we can click at any point. There we go. You can see deflection was an important one. So we have the ratios there, the limit ratios. We have our stresses, crack widths as well. Crack width's an interesting one. So with crack widths, you can enable automatic correction. What that makes sure is that it will make sure that it doesn't exceed that, say, 0.4, 0.3 millimeters in any case. It'll make sure it doesn't go over that. So there's our support reactions at a quick glance. Very easy to get those out. Now then, over to the interactive drawing. Very much the same as what we saw with the steel connection. We'll have an elevation, a couple of sections. There we go. Regarding the elevation, you can add the information on there, depending on what your requirements are. You can add in, for example, number of bars or number of bars and the centers, the bar mark as well. It's all down to you. So we've got the bar schedule there, bar bending schedule. You can have it on a separate sheet. There we go. Bar bending schedule and the drawing zone. So all of that in one place there. Again, very similar. We can save this as a DWG as well. actually then open it in AutoCAD, make any changes to it. Okay, so that is very, very similar to the steel design. Okay, so now just realised we've gone a little bit over time here. If you have any questions, any other questions that you can think of, please put them in the chat box. I can see some questions in the question page. Okay, so what are the questions that we have here? They're from Ashley Kutcher. Hope I pronounced that correctly. Hi, Ashley. Ashley says this is to do with what we saw at the beginning, the Gtcx change. He says, does the X in the Gtcx indicate an XML file? If so, is this directly editable through a text editor /script? Okay, so Ashley, this the X doesn't necessarily refer to an XML file because a Gtcx file is just it's a common file. I can look into that for you a little bit more and get back to you on that. Yeah, so from what I understand, that the X doesn't stand for an XML file because it doesn't save it as an XML. It saves it as a Gtcx file extension, which is a bit different to an XML extension. So I hope that answers your question. If you have any other questions, I can't see any others at this time. Once again, you've got a copy of this handout. I will also put my email address in the chat box once again for any of you who may have missed it. So there you have my email address. If you have any other questions, which pop up later in your head, feel free to send me any questions to my email address, and I'm happy to pick those up. I've just had another question come in. This one is from Subabrata Kumar. Hope I've pronounced that one right. He says, so they say in Advance Design help file. Okay, so this one is related specifically to the section properties. Okay. Subabrata, yes. Can you send me an email with this, please, with a screenshot as well? I can then explain that in a little bit more detail for you. Okay, so that one's a bit more involved. Right, okay, so it doesn't look like there are any other questions. I'll just give a couple of moments for you guys if you've got any questions, and then I'll look to conclude this session. Okay, so it doesn't look like there are any other questions. So I hope you enjoyed today's session. Hope you can see how easy it is, just how easy structural design should be, well, how easy it is with Advanced Design here. One other question. Sorry, yes, I've just put my email address in the chat box. I'll just put it in there for you again. Subabrata, okay. So there's my email address. Right, if I now show you what's coming up next. So coming up then, again, stay tuned. Tomorrow at the same time, we've got the structural design workflow with Revit. So tomorrow the focus will be on in Revit, where I will be looking at concrete structure in Revit and the design workflow for that. So that's a very interesting one. Make sure you stay tuned for that. Don't miss out on that. You'll absolutely love that one. Okay, so once again, thanks for joining me today and watching today's webinar. As always, please follow us on social media, on our Twitter page, Facebook, LinkedIn, and YouTube. We regularly update our pages with the latest content for you guys to enjoy. So it's bye from me for now, and I look forward to seeing you guys on tomorrow's session. Bye for now.